Oh, good afternoon. I'm Mr. Precella, and we are looking at circles today. And uh, in a college level algebra course, we make the assumption that you're familiar with the geometry of a circle. You know what a circle looks like. And you know that there's a dot in the middle that's called the center, and that the distance from the center to the outer edge, what's that called? The distance from the center to the outer edge?
Radius.
The radius, okay. So that distance from the center to the outer edge is the radius, and it's the same at every point on the circle. I'll go ahead and write in the word center right there. We're going to take an algebraic approach to circles. That means, well, algebraic, that means there's going to have to be some variables, okay? So here we go. For the center, we're going to denote it with the ordered pair HK. For the radius, what letter do you think we're going to use to define radius, or to describe radius? Should be obvious. R, yeah. We have something called the center radius form for the equation of a circle. Center radius form. Center radius form requires that you know something about the center and the radius of the circle in order to use that form. And it's sort of, it may look a little messy, but don't let that scare you. I'm going to fill in the spaces that I left there. It's x minus the x coordinate of the center quantity squared, and then y minus the y coordinate of the center quantity squared equals, and on the right side we have the radius squared. That's a lot of letters. That's a lot of letters floating around there. Realize that x and y are the only variables. Those are the real letters. H, K, and R, they're going to be numbers in the equation. But x is a variable, and y is a variable. There's a built-in graphing tool for circles in this assignment that is just great. Draws perfect circles for us. And I'll illustrate how to use that as we go through the assignment. Let's look at number 1. I was wondering, these assignments were not, these lectures were not from last semester. Last semester I was, Tony was at a committee meeting, and so I did the whole thing by myself, and it took about almost 2 hours. I worked every one of the problems, going through a leisurely pace, and Tony said, that video's too long. So we used 2 of the shorter ones, and Tony's here, speeding me on the way. But here we go. Number 1. Let's see, there. Let me see something else. Where's there, I think that looks better. Okay, find the center radius form of the equation of a circle with center at 0, 0 and radius 11. This is number 1. Let me write it down. I'm going to write down the important information. Center is 0, 0, radius is 11. So I'm going to use a capital C as my lazy way of saying the center is at 0, 0, and they said the radius is 11. That's a semicolon there separating those two. I don't know why I put it. For the center radius form, we know you're going to have x minus the x-coordinate of the center squared plus y minus the y-coordinate of the center squared. And on the right-hand side, we'll have the radius squared. Well, what number is acting like h in this problem? 0. The x-coordinate of the center is 0. What number is acting like k? 0 as well. This is one of the circles that are centered at the origin are by far the nicest of the circles. You'll see when we start graphing them. Now, obviously, the radius is 11. So I'm going to write out x minus, I have a y minus, and on the right-hand side, I'm going to be squaring the radius. I need an h there, so that's a 0. Y minus, k is 0. And what am I going to square here? 11. And in this case, most of the time with center radius form, you don't want to do much to simplify, but this one can be reduced quite easily. X minus 0 is just x. So x squared plus, how can I clean this up? Y squared, and 11 times 11 is 121. So here's my center radius form. Any questions there before I switch over and type in the answer? Realize circles, you expect there to be x squares and y squares. Do equations of lines have x squares and y squares? They just have an x or y, may have both, but they can't have those exponents. That'll be relevant in a little bit, in about an hour. But for right now, here we are. They want us to type in the center radius form. You've got to type those parentheses, and I don't use these parentheses, this hot button, because that's for an ordered pair. We don't need a comma down there. If I need to type a parenthesis, I just use the keyboard. Left parenthesis. X. Oh, no, I don't even need a parenthesis, do I? Not on this first one. Superscript, square, right arrow, get out of that exponent position, plus y, superscript, square, get out of that exponent before I type equals 121. Any questions there? Then they want us to graph the circle. I should tell you right now, you don't need the equation in order to graph the circle. They gave you everything you need. They gave you the center, they gave you the radius. They could have just as easily said, draw the graph and then write the equation. I'm going to expand it. I like this one here. And I click the tool. Only one of these things looks like a circle right there, the circle tool. And if you, it's too dull for you to tell, but the center dot there is blue, and then there's one other dot there on the edge of the circle. You're going to need so to use the circle tool, you'll need the center and one other dot. Let me expand those instructions. We click the circle. What does it say to plot first? The center, 0, 0. Remember, right there in the yellow box, above that little V, or underneath that X, that's showing you where the pointer is. So if it's like in these small units here, it's easy to look up here and see where your pointer is. So now look at what it says to do next. It says click the graph to plot a point on your circle. You need to find a point on that circle. That's where you use the radius. The radius tells you that you're going to move 11 units in any direction. We could try to move 11 units diagonally, but that's hard to count. So it's either going to be up, down, left, or right. I think I'll move up, 11 units up. Am I 11 units up from 0, 0? What are the coordinates of that point that I've stopped at? 0, 11. That's right. And notice I'll say, okay, let me clear it. Yes. Let me do it again. Okay, 0, 0. There. Then I went up to 11. Don't let this mouse move. We used to have mouse pads in these classrooms. I don't know what happened to them. And notice if you counted 11 units to the right, you'd be right there at 11, 0. If you'd gone 11 units to the left, you'd be over there at negative 11, 0. So you could go either up, down, left, or right. Go whatever's easiest for you. You click the center, then you use the radius to find a point that's on the circle. Save it. And check answer. Yes. Any questions there? Well, they can't all be centered at the origin, okay? Let's look at number 2. Same instructions, find the center radius form for the circle. The center is at negative 2, 1. The center is at the ordered pair negative 2, 1. And the radius is 2. Okay. Good. Okay, well, we know we're going to have to know our h and k. What number is acting like h? Negative 2, the x coordinate of the center. What number is acting like k? 1, the y coordinate of the center. And this is obviously r. I'll write my x minus and my y minus. There. What number is going to go right here? X minus the x coordinate of the center, so negative 2. Y minus the y coordinate of the center is a positive 1. And what number is going to go here? The 2, that radius. And for center radius form, you don't have to do that much to simplify. Deal with just the, or here, x minus 0. That was an obvious simplification. There's something obvious here that we can do. X minus a negative, what does that become? A positive. So it's an x plus 2 quantity squared plus y minus 1. I'll just leave that as y minus 1 squared. And on the right, what have I got? 2 squared is 4. I agree. Question? Question? No?
Not yet.
One thing that you're going to need to notice, in a moment, they're going to start giving you the equation, and you'll have to go back to the center. When you look here, because of the way the formula has those minuses, what you see inside the parentheses is exactly the opposite of the center. I see a positive 2. The x coordinate is a negative 2. Here I see a negative 1. What's the y coordinate of the center? A positive 1. That's going to be an important concept. What you see inside the parentheses is exactly the opposite of the center. Hey, in a little bit they'll be giving you the equation and you're going to have to go backwards. What are you going to do to this number on the right-hand side in order to go back to the radius? Here I see a 121 on the right. What do you do to go back to that 11? Take the square root. You're undoing that square. So in a little bit we'll be change sign, take the square root. But at this point, all we got to do is type in that answer. We need a parenthesis, so just use the parenthesis from your keyboard. X plus 2, right parenthesis, your superscript square. What do I need to do?
Move moved out of that.
That move out of that exponent before I put the plus, then left parentheses again, y minus 1, right parenthesis, superscript, square. Get out of the parenthesis before you, the exponent before you type equals 4. Now we click our graph. This is a circle. We have x squares and y squares, so it's a circle. And the center is at -2, 1. Is that it?
Yep.
Yes, that's the center, so I'm going to click there. And notice as I move my mouse around, it's drawing every possible circle that's centered at -2, 1. Well, it says to plot another point. Let's start here. Why don't we count up? We could count down, left, right. Let's count up. What was my radius? 2. So I'm at 1. I'm going to go up 2 units. 1, 2. Click. Notice if I'd counted 2 units to the right, or 2 units down, or 2 units to the left, I'd still get a point on that circle. Save it. Check answer.
So you just go back to like the original.
You don't use the equation when it comes time for graphing. You need the center and the radius. You plot the center, you use the radius to find an additional point. That's why I said they could have just as easily said, graph the circle and then write the equation. But they didn't. Any other questions there? Number 4. Find the center radius form of the circle and draw the graph. Here the center is at 1, 0, and the radius is 5. This is number 4. Number 3 was just like number 2. If we have time, we'll come back to it, but I can't get this page apart. Okay, so this is number 4. The center is at 1, 0, and what do they say the radius is? 5. I remember back in the olden days when we worked the problems from the book. I'm ashamed to say I'd have the problems memorized, and I could just for having done them so many times, teach 3 college algebra classes during a semester, and use the same book for years, and I'd amaze the students with my ability. Okay, we'll do number 7. The radius, they'd be looking, trying to see, write the equation of a circle with a radius of, what is it, 4, and centered at -3, 7, stuff like that. They'd be amazed the way I'd remember the problem. So we got it written down. There. Here. What number's acting like H? Okay, that number, the x coordinate of the center is H. What number's acting like K? 0. And obviously the radius 5. So x minus y minus. Y'all tell me what number's going to go here? 1 here, 0 here, 5, and so it's x minus 1. I'm just going to leave it as x minus 1. I can clean up that y minus 0 squared real nicely just to be y squared. I agree. And on the right hand side, 25. So far it's going pretty good, isn't it? It's not too bad at all. Yet. Any questions there? Left parentheses, x minus 1, right parentheses, instead of using the that hot button, that square superscript button, have I mentioned the shortcut for you? Is it shift up arrow? The shift up arrow at the same time will get you in that exponent position, where you type the square, then get out of the exponent position, plus y. Instead of using the little superscript, I'd like it better if they said make the right exponent rather than superscript. What do you think? And I keep, every year I mention that to the Pearson people, and one day they'll decide, oh, okay, and they'll do it. I'll probably be retired then. Surely not. But the Pearson programmers do listen to the faculty, and so they may get it done one day. Click, and there. Okay, so I'll click my circle tool. Then the center was 1, 0. Is that it? 1, 0? Yes. And then it puts the radius? 5. Y'all tell me how you want to count. You want to go up, down, left, or right. It makes no difference to me. Up, 1, 2, 3, 4, 5. Is that where I want to be?
Yes.
Click it. Save it to transfer it over here. Check answer. Any questions there? So far, it's pretty painless. They want us to graph the circle. They're not giving us the center and the radius. Remember what I said earlier? Let me see something. Wait. That's so similar now. Okay. Let's see. Okay, we'll do this one, number 6. They give us the equation x minus 3 quantity squared plus y plus 7 quantity squared is equal to 9. And some teachers that don't use this program don't use it because they say the numbers get too messy. You can't control the numbers. That's right, but it's nice in a way. They're going to make sure that this number here is a perfect square for you. You're not going to wind up with an 8 there, and you have to estimate, how do you move the square root? That's a 2 point something. How do you move 2 point something units to get that second point? So one of the nice things about this program, they'll make sure, even though everyone's problem will be different, they'll make sure it's rigged so you have a perfect square here. Because trying to count, oh, I need to move the square root of 7 units up. How are you going to do that? Anyway, remember what I said. In order to draw a graph of a circle, we need to know the center, and we need to know the radius so we can find a second point. Remember the way that center radius form works. There it is. There. What you see, because of the way the formula has those minuses, what you see inside the parentheses is exactly the opposite of the center. Minus a negative, that becomes a positive. So you see a plus 2, the x-coordinate of the center was a negative 2. You see a minus 1 or a negative 1, the y-coordinate of the center was a positive 1. You see a 4 here. What do you have to do to undo that squaring? You take the square root. Change sign, take the square root. If you understand that, you can tell me the center. Where's my green pen? Okay, change sign, so that becomes a positive 3. Change sign, a negative 7. I agree, 3, negative 7 is the center. What's the radius? You take the square root of that number, and I know you can do that in your head, but I'm just writing it out so when you're at home looking at your notes, you remember what we did to get that radius of 3. So we come over here, we're going to graph the circle. Right there. I click my circle tool. I plot the center, 3, -7. Is that it? No, I think I'm at 4, aren't I? There it is. Is that 3, -7? Yes, I click it. The radius is 3, so we can go up, down, left to right. I have an idea. Why don't we go down? Because isn't it going to drop us at the very bottom of the grid? If we count down 3 units. 1, 2, 3. Oh, those big dots, they still tickle me. The tiniest things amuse me, I suppose. And check. Any questions there? So change sign, take the square root, and that's going to be important. So let's do another one. Number 7. Let me write the problem down. I remember in the olden days having the chalk and the string, trying to draw the circles on the chalkboard. Oh, goodness. Oh. People that say those were the good old days, they're saying it just because they were younger. And I let y'all in on a secret. People that say that, they're saying it just because they were younger. And arthritis hadn't set in on the fingers, hadn't gone through months and months of chemotherapy. I tell you, the people that say that was the good old days, it's just because the people saying that were younger back then. I'm sorry to tell you, this is so much better. And I'm waiting for y'all to tell me there's only one correct first step. Find the center, okay. Finding the center, -2, and -5, I agree. We need to know the center if we're going to draw a graph. What else do we need to know? The radius, what are we going to do to find the radius? The square root of 16, which is 4. You know, if you're going to be taking the square root to get the radius, what do y'all think? Could this number over here ever be negative? No, because if you took the square root of a negative, you get an imaginary number. And if you think of it here, something squared, so non-negative, since you're squaring it, doesn't matter what you plug in for x. When you square it, it won't be negative. Non-negative plus non-negative, can that ever equal a negative? And we'll discuss that more as we get into it, because this number, in order for the equation to be a circle, it has to be a positive number. Fortunately for us, it's also going to be a perfect square to make it easier for graphing it. So we come over here. I wonder if I do this. Do y'all graph it like this, where you just use the tool down here? Let's see. Where are the instructions? If I do this, where does it show what to do? Where is it? I don't see where it says the instructions. I click circle. That's one of the reasons I prefer to do it here. Okay. Click circle. And now we find the center. What did y'all say it was? -2. Is that it? And then the radius was 4. What do you want to do? Up, down, left, or right? Go down. 1, 2, 3, 4. Click it. Save. Click. Any questions there? As long as the circle is written in center radius form, it's easy to determine the center and the radius. Change sign, take the square root. Well, suppose someone decided that they were going to go through and remove the parentheses. This is a binomial squared. A sum or difference being squared. You can't just say it's x squared plus 4 squared. What do you do if you have x plus 2 times x plus 2? What do you do to expand an x plus 2 squared? Starts with an F. Well, okay. Let's get started. Now, keep in mind on your own, for your own answers, that's something you never want to do. Let me show you what we're about to get to. Number 8. Someone's gone through and FOILed out everything. It's not so easy to look and determine the center and radius anymore. You're going to have to take the step that somebody has expanded and go backwards to center radius form. So with that in mind, let's write it. X plus 2 times x plus 2 plus, what am I going to do with that y plus 5 squared? Oh, wait, Tim. Switch it over. Thanks. I had forgotten to do that a single time. When you were gone, I seem to remember it pretty well. We reflected on the good old days and what that means when people say the good old days. When you were younger. Oh, okay. Am I wrong? That's the good old days. Y'all are still young. Y'all may not have had good old days yet. But, so we write it twice, and then we start FOILing out. That's an x squared plus outer is 2x, inner is 2x, last is 4. So that simplifies to an x squared plus 4x plus 4. Now let's do the y plus 5 times the y plus 5. First,
Y squared.
Outer,
5y.
Inner,
Another 5y.
Last, and here we can combine the 5y plus 5y. That'll give us a plus 10y. Okay. And now let's suppose we're going to write the terms with the largest exponents first, based on descending power exponents. You say, well, we have an x squared and a y squared. Let's put those in alphabetical order. So you can decide which one goes first. We'll write the x squared first, plus the y squared, and then the unsquared variables. We have a plus 4x and a plus 10y. And let's see, 4 plus 25, that's 29, equals 16. What we're doing here is called expanded or general form. I prefer the term expanded form. You're expanding those squares. I'm trying to make a point here, okay? He's already done 7, but it's just getting you ready for number 8. I would then, let's say, suppose we then decided, okay, let's move the 16 over to the right by doing, to the left by doing what? Subtracting, so we have x squared plus y squared plus 4x plus 10y plus 13 is equal to 0. And as I said, this is called expanded or general form, and there's really no time in an algebra class when you would want to expand it, to write it like this. I remember doing this in relation to implicit differentiation in a calculus class, going through removing the parentheses. But in an algebra class, there's really nothing nice about this form. With center radius form, change sign, take the square root. With general form, is it so easy to determine the center and radius?
And you look at this and decide the center and radius.
Change sign, take the square root?
No, not in this form.
Not in this form. We're going to have to do something called completing the square. We were looking at completing.
Wait, can I put in something? We're about to start with this and go backwards. Just like I've mentioned before in algebra, you always do it one way and do it in reverse.
We're starting here. We've got to go back to this form here. This x squared plus 4x plus 4, that's called a perfect square trinomial because it factors as a binomial square. Y squared plus 10y plus 25, that's another perfect square trinomial because it factors as a binomial square. Y plus 5. We're going to have to, hey, when you look here, we have this 4 and 25 that came about from squaring the 2 and squaring the 5, but they don't even appear here in this final answer. Our constant is a 13. Where are we going to pick up that 4 and the 25? And how are we going to get this 16 so we can take the square root and get the radius? Well, we need to notice something about some perfect square trinomials. Okay, I'll give you a moment before I turn the page. I'm going to give you some examples of perfect square trinomials. Well, we have two.
X squared plus 4x plus 4 is equal to x plus 2 squared. Y squared plus 5y plus 25, that's y plus 2 squared.
Y plus 5 squared.
Y plus 5 squared. What does that say? Y plus
question. Okay, so we're looking at perfect square trinomials. Any questions?
Well,
We're just now.
Right.
So this is the
the
expanded form of 7?
That's expanded
But
form.
you
in
didn't
number
need to
7.
do number 7. He's just getting, okay.
Trying to get you ready for what we're going to be doing.
Okay.
On number
You didn't
7.
need to do it for 7, it's just
No.
an example. Where you
It's an example.
This is number 7. To get the center, you change the sign, take the square root. On the very next one,
I already showed.
you got to, I know, but I'm going to show them again. The center and radius, you got to find that. But notice how it's not in the nice form.
Right.
Okay? Someone went through and foiled it all out. So how the heck, let me move back over here. It's going to involve factoring perfect square trinomials.
We just saw two perfect square trinomials. The x squared plus 4x plus 4, that factored as x plus 2 quantity squared. The y squared plus, what's it,
5? No, 10y plus 25.
that factored as y plus 5 quantity squared. You're going to be looking for patterns. Realize what you have at this point. You're going to have to, what we have in the expanded form, you have the x squared and x, the y squared and y. It's this number here that's missing. That x one isn't a good example, okay? But this one here, we have y squared plus 10y. Be thinking, what sort of stuff could we do to, I guess the only number I would see there is a 10. What could we do to 10 to come up with that 25? Here's another perfect square trinomial. How about x squared minus 8x plus 16?
Write that as two sets of parentheses. Factor this.
Yeah, let's factor that.
Are you going to get the same thing in both sets of parentheses?
Yes.
Okay, the second sign's a plus, so you have two of the first signs. Okay, what times what gives you 16? 4 times 4. That should make you think of something. This number here, if you're going to be able to write it as a perfect square, you have to be able to use that same number right here where I'm pointing. So this number here had better be a perfect square. 4 is a perfect square, 25 is a perfect square, and once it's factored like that, you can write it as x minus 4 quantity squared. What can we do? I made that thing up off the top of my head. Here's another one. How about x squared minus 6x plus 9? How will that thing factor? X minus 3 times x minus 3, which is the same thing as x minus 3 quantity squared. And
How about y squared minus 12y?
okay. I'm going to let y'all figure out. You're going to create a perfect square now, okay? Y squared minus 12y plus.
It's got to be a plus.
It's got to be a plus because negative times negative is going to give you a positive, and you want to have the same thing inside the parentheses. That's what makes it a perfect square. You have to have the same signs, whether it's plus or minus. When you multiply them together, it's going to give you a plus. Stop and think. What perfect square could we put there to make this into so it factors as y minus something quantity squared? Think about 6. What could I do? I think I heard that hint.
What'd you say?
36.
I think that's it. You see the pattern. Working with 12. Remember the way we were going through pulling out? We started with, we have a 4, but the expansion originally involved half of that, 2x and 2x. We ended here with a 10y, but the expansion involved a 5 and a 5. Correct? So you took half of 12. Here's what you're thinking. Half of 12 is 6.
Oops, what did I do?
But then, what do we do to 6 to give us 36? Square it. Okay, and you say, well, how did that number get squared? It's easiest to look here. 5 times 5. Remember last times last? That gave us that perfect square of 25. So we took half of 12, which is 6. Then 6 times 6 is 36. And then that's going to factor how? It's going to be a y. Whatever that sign is, if that were a plus, we'd use a plus. If it were a plus, you have a plus. If it's a minus, you have a minus. And what number goes here? 6. Variable, sign, half of that number.
Why not right here, draw an arrow and say, take half, then square it. That's how you get to 36.
Take half
Half of 12.
and then square.
Half of 12 is 6. 6 squared, 36.
Look at this. What's half of 8? 4. 4 squared is That's how we come up with that 16. And you say, well, I'm ignoring that minus. Yes, I am. Half of negative 8 is negative 4, but negative 4 times negative 4 is going to be what? So this number here is always going to be positive. Half of 10 is 5 squared is. There's the pattern. And I think this is a good time for you to pass out your leaflets to everyone.
Oh, I thought I'd given them out to most people, but maybe not everyone got a leaflet. Did everyone get, who didn't get a leaflet? Oh, I didn't give you one.
Oh, and this leaflet is under Files on Canvas. So if you lose it, it's under Files on Canvas on the college algebra course. People are still trying to use, I had a student from the online class trying to use the 314 Canvas course to take the 314 quiz. All coursework is under the college
I think
algebra
maybe this
Canvas
week we'll
course.
do away with that.
I am going to unpublish the 314 Canvas courses. I'm going to put the syllabus on the homepage of the College Algebra Canvas course, so there will be no more confusion. When do you use the 314 Canvas course? You don't. All the coursework
And could
is
you
in
change
here.
the name so it says 314/1314
I
on the
can do
Canvas?
that. I can do that. Okay. Let's look at number 8, and we're going to follow this little recipe that we have.
It says find the center and radius.
This is number
And then
8.
draw the graph.
X squared plus y squared minus 10x plus 4y is equal to 35. Realize what we're trying to do. Switch to my paper. Our work is going to look sort of like what we were doing here, going backwards. Our goal as we do this is to get it in center radius form. Here's the goal. X minus, y minus, and a number right there.
So you can go change the sign, square root.
I guess I shouldn't use that. That looks like a hashtag. And in the olden days, well, I know, in the olden days, that little pound symbol represented a number, okay? So this is a number here. Hopefully a positive number. Okay. First thing I'm going to do, I'm going to look and ask myself, what's the leading coefficient? What's the leading coefficient here? These perfect squares, remember inside the parentheses, it just has to be a variable. It can't be anything else. It's just a variable. It can't be a 7y inside there, just a variable to get it into center radius form. So I have to look and ask myself, is there a coefficient on those squared variables? If so, then we're going to have to divide through by it. Look at the... Oh, I don't think I have the form. Well, give me just the handout. I don't recall downloading that circles handout on the display. So look right here. Writing equations of circles in center radius form by completing the square. Completing the square is this process of creating perfect square trinomials. To rewrite ax squared plus ay squared plus cx plus dy plus e equals 0 in center radius form. If a doesn't equal 1, divide each term by a. That number in front of x squared and y squared has to just be an assumed 1. And in this case, it is. So we skip the first step. The second step, rewrite the equation by grouping the x terms together, followed by the y terms. Then isolate the constant term on the right side of the equation. Really, we're going to group the x terms. X squared minus 10x, I'll put those in purple. X squared minus 10x plus, skip some space. There's no way to write that, to type that as a sequence of steps without it sounding weird. But
Yeah, I
really
remember
it's
trying to do that years ago.
Rewrite the equation by grouping the x terms together, comma, skip some space, plus the y terms together. We have a y squared plus a 4y. Skip some space. And in this case, they want the constant on the right-hand side. This problem already has it on the right-hand side. So they did a little bit of nice thing for us there, having the constant on the right-hand side already.
Why don't you go ahead and draw the two blanks on the right? Because eventually we're going to add a purple number on the left and a green number on the left, which means we got to, whatever we add to the left, we got to add to the right. So we're going to
maintain the equality. Whatever number we put here, we're going to have to put it on the right-hand side of the equation. Whatever number we put in this green blank, we're going to have to put on the right-hand side in this green blank here. Steps 3 and 4 are those magic steps we go through creating perfect squares. Look at what it says. Step number 3. Divide the coefficient of x by 2. Remember, you don't need to worry about the sign. That takes care of itself.
And this you can usually do in your head. Divide the 10 by 2.
To give me.
Or maybe you can't do it in your head.
10 divided by 2 is 5. And then look at what was that other thing we do?
Square.
Square the number we just found. Isn't that what we were doing here? Take half of 12, then square, take half of 12, and then square it to get the 36. You take half of 10, that gives you 5. Then you square it. 5 times 5 is 25. You put 25 on the left side. Step number 5.
And on the right.
Add the number found in step 4 to both sides of the equation. I know, Tony. So we put it there, we put it there. Step number 6. Repeat steps 3 through 5 for the y terms. This process is called completing the square. Finding that number that we're getting there, that perfect square, so we have a perfect square trinomial. So we're repeating step number 3 for the y's. Divide the coefficient of y by 2. The coefficient of y is, well, the coefficient of y is 4. 4 divided by 2 gives me 2. Here's my scratch word. Then what do we do with that 2? Square it. 2 times 2 is 4. What do we do with that 4? You add it to both sides. It goes there and right there. Remember your goal. Your goal, you want the binomial square plus binomial square equals a number. We should be able, we just finished step number 6, doing the stuff for the y's. Step number 7, factor the x terms as a perfect square trinomial, and then factor the y terms as a perfect square trinomial. If you do that correctly, the equation should be in center radius form. So we're going to factor.
Tim, I forgot to mention what should be obvious. Add these 3 numbers over here. The 35 plus 25 plus 4. I don't list that as a step on there, and you don't either.
Well, simplifying the right-hand side, 25 plus 35, that's a 60 plus 4. What are we getting over here on the right-hand side? 64. Okay.
So at this point, you can tell me, what's the radius of this circle going to be? You're going to have to change the sign, and then square root. So what's it going to be? 8? Yeah. Let's put it here.
Okay, so working here with the perfect square x trinomial. These things have a pattern. They factor very nicely. Look back up here. Variable, sign, half of that number, variable, 12. The sign, so a minus, half of that number was 6. So with that in mind, variable, x, sign plus or minus, minus Half of that number, 5.
Or you might say square root of that number there. The square root of 25 will
No.
get it to you also.
Variable, sine, half of that number is 2.
Now, can we do change the sign square root? You know, looking at it like that, Tim, it doesn't look like a long problem at all. You did
It
one
is,
line of work.
Mm-hmm.
Well,
But I
two.
still have to go through the whole expansion for them to see that we're going backwards at this point. What's the center of the x coordinate of the center?
5.
5. Change sign. The y coordinate of the center.
-2.
The radius.
8.
You took the square root of 64, which is 8.
So 5, -2.
We did that work so that we know the center and the radius, so we can draw the graph.
Oh, they don't ask us to type in the center of radius, so what was it?
5, -2 is the center.
Okay, so first circle, plot the center. What do you say, 5, -2?
Yes.
Oh, each mark is 2, is it? Okay, so that's 5, -2. I'll look in the upper right-hand side of the yellow rectangle, so I'm correct there. And now it says move back. Well, y'all have already been graphing, so
Yeah.
so move over. How are you
The
going to move?
radius
Left,
is
right,
8.
up, or
What do
down?
y'all think? We're at 5, -2. How about we move to the right 8 units? If we're at 5 on the x-axis and we're moving over 8, 5 plus 8 is going to drop us off at what? 13. So look at that. Do y'all see there in the yellow box? I'm going to 13. Oh, I think I moved down. Is that it?
No,
That's it. That's
Oh,
not
no.
it.
I thought we
Is
were going
that it?
13, -2.
There it is. You could have gone up or down, but it seemed to me count here. You're dealing with positive numbers. +5 plus 8 left you at +13. So save it. Check it. Any questions there? Okay. Number 9.
Notice here it doesn't say find the center and radius, but that's the only way you can graph it. It's impossible to graph a circle without knowing that center and radius. It'd be like trying to use an old-fashioned compass without knowing where to put the sharp point and how far to open it up.
X squared plus y squared. Okay. Okay. Group the x terms together. Well, first of all, what's the leading coefficient?
Just a 1.
So that first step, divide through by a. If a isn't equal to 1, we just skip. I'm sure there will be at least one problem where the number in front of x squared and y squared is not a 1. So far, it's still just a 1, but I bet you there'll be we'll get to a point where it's something other. Oh no, it's an x squared. Group the x terms together, x squared minus 8x, plus skip some space. Then group the y terms together, y squared plus 8y, plus skip some space. What are we going to do with this -4 here? What are we going to do with that? Move it over. That gives me a +4. Realize whatever number in the blue blank we add on the left side, we'll have to add it to the right. Whatever number gets put in that purple blank on the left will have to be added to the right as well.
Hey, this is going to work out pretty nice because the blue number and the purple number that we're going to add in are both going to be what? How do we find it?
What do? We start with the coefficient of x. First thing we do is we divide it by 2. That gives us a 4. And then square it. 4 squared is 16. So we have a plus 16 there. Here, that's going to be the same number, 16. So we'll factor the x's as a perfect square. We'll factor the y's as a perfect square. What have we got on the right-hand side? Okay, 4 plus 16 is 20, plus 16 gives us 36. I agree. I need to get this into center radius form. What sign am I going to have here in these parentheses? We're looking at that 3x terms. So it's x, sign, minus, number, 4. Variable, sign, half of that number. For the y's, what are we going to have? Y plus variable, sign, another 4. Half of 8 is still 4. What's the center? Okay. Change sign, change sign. What's the radius? You take the square root of 36, which is 6. Any questions there before I switch screens? We click our circle tool. The center is 4, negative 4. Is that what I wanted? Yes. And then what's the radius? 6. So what do y'all want to do? Up, down, left, or right? It makes no difference to me. Right? So we're going 1, 2, 3, 4, 5, and 6. 4 plus 6, what number are we at there? 10, is that what we needed? Ah, there it is. And check. And let's see. One more. Well, there's several more, but on number 10, let's see. Find the center and radius of the circle. 4x squared plus 4y squared plus 16x plus 24y plus 36 is equal to 0.
Oh, wait, were you not through?
I was just making sure I wrote down the right thing. 4x squared plus 4y squared plus 16x plus 24y. Okay, now switch. Okay. There's a fundamental difference between number 9 and 10. What is it? They have coefficients here. If you think about it, with standard form, I mean a center radius form, if you square x minus 4 times x minus 4, you're going to get an x squared. You're not going to get a 4x squared. You shouldn't have numbers in front of those square terms. Someone went through and multiplied that whole thing by 4 to get that 4 in front of x squared and y squared.
Why they did that, I can't imagine.
But the general form, not general form, center of radius form requires coefficients of 1. So if you look here, the first step, if A isn't equal to 1, divide each term by A. So A is a 4, go through, divide everything by 4. That's the same thing as multiplying 3 by 1/4. That's why we're able to do this. And that gives us 1x squared plus y squared plus here, I'm waiting, 4x plus here, 6y plus 36 divided by 4 equals 0 divided by 4 is 0.
Now isn't this problem, doesn't it look just like number 9?
Yes.
Yeah.
So you group the x terms together. You have an x squared plus 4x plus, skip some space, the y terms. You have a y squared plus a 6y plus, skip some space. What am I going to do with this 9? Move it over to the right to have a negative 9. And you have those 2 blanks there. What's going to go in the purple blank? You take this 4, you take half of 4. 4 divided by 4 is?
No, half of 4. 4 divided by 2.
4 divided by 2 is? Isn't that what
4 divided by 4.
Oh, 4 divided by 2 is 2, and then 2 squared is 4, so we put 4 in the purple blanks. Now the 6y. What number's going to go in the blank? 6 divided by 2 is? 3. 3 times 3 is? 9. So we put the 9 and the 9.
So you always divide it by 2, right?
That's what you do. Just like here, you divide by 2. 8 divided by 2 is 4. Then 4 squared, that's where you got the 16. So we'll group the x terms together. Group the y terms together. Oh, the right-hand side works out very nicely. We have a negative 9 plus 4 plus 9. That's just a 4. Negative 9 plus 9 goes to 0, so you're just left with the 4. You tell me what's going to go inside the purple parentheses here. Okay, variable, sine, half of 4 was 2, I agree. What's going to go inside the green parentheses?
Y plus 3.
Okay, variable, sine, half of 6 is 3. Is this in center radius form? Can we look and determine the center and the radius? I'll tell you right now, it is in center radius form. Tell me the center.
-2.
Okay, change sign, -2. Change sign, -3. What's the radius?
2.
The square root of 4 is 2, I agree.
Mm-hmm.
Although, the answer, I suppose, is... Oh, wait, we're not graphing this.
Yeah, that's it.
This is a multiple choice. They wanted the
Wait, so
center
it's
and the radius.
-2, -3, 2. Okay, so let's look real close. -2, -3, radius 2. C?
C. C.
Okay. With the general form,
You're going to write something?
yes, I am. With the general form, x minus h quantity squared plus, not general form, but center radius form, y minus k quantity squared equals r squared. In order for this equation to be a circle, we said this number here on the right-hand side has to be what?
Positive or negative?
Positive.
Positive. Okay, so if it's positive, you have a circle. Suppose that you went through and this number here were negative. Okay, you've got a negative number here. You're trying to take the square root. What do you know about the square root of a negative number?
It's imaginary.
You wouldn't get a distance that you can move. It's an imaginary number. If this number is on the right-hand side turns out to be negative, then you have no circle. You have no graph at all. There's one other interesting case. There's one, yes, 0. Suppose it's neither positive nor negative. 0 is neither positive nor negative. So suppose you'd gotten a 0. You could find the center. You could find the center, change sign. But how many units up, down, left, or right are you going to move from the center? 0. The square root of 0 is 0. So if that right-hand side reduces to 0, all you have is a point. You have that center point, and that's it. I'm mentioning this. Yeah, it's down here. Okay, notice right here, he has it typed out. If r is equal to 0, the graph is not a circle. The graph is just a point. Now, if r is imaginary, you're taking the square root of a negative number, then no graph, not even a point, exists. So he mentions those two special cases here on his little recipe for completing the square.
Way before videos, we had little leaflets.
You've already said that.
I know, but I'm saying it again.
And this is one of those leaflets that he kept up with.
Uh-huh.
So,
I used to have leaflets for pretty much every
everything, I
assignment.
know.
Only ones that
Shuffling those
survived the
papers.
circle.
Oh, you were absent. Oh, let me see what paper. Oh, right here. Oh, goodness. Oh, the good old days.
Good old
right?
days. You're right, man. Now let's do number 11. Is that the one we're doing?
12.
Oh, 12. Okay.
We'll do 12, 11, and then 13.
Now
Yeah,
look
but-
at the instructions.
Decide whether or not the equation has a circle as its graph. If it does, give the center and radius. If it doesn't, describe the graph. Well, look at the four options here. The graph of the equation is a point. Well, if it turns out r is equal to 0 at the end, that's the thing we would choose. The graph of the equation is a line. That's the one I want to mention. That option B. Look at number 13.
Number 13.
You look at number 13 for a minute. Every one of these multiple choice things gives that possibility. The graph of the equation is a line. Do lines have exponents in them? No. And so you know it's not going to be a line. If you're going to guess blindly, don't guess that it's a line because lines don't have exponents. But here we go. So we know it's not going to be a line. Now to answer what sort of circle it's going to be, we're going to have to write this thing in center radius form. This is number 12. So x squared plus y squared plus 4x minus 8y. Is that a plus 29?
Mm-hmm.
Equals 0.
So even though there's all those instructions, you're still going to start it the same way.
Writing it in, getting it in center radius form by
I used
completing
to
this
not
square.
like these instructions because I thought it made it sound like it says decide whether or not. It looks like, it makes it sound to me like you're supposed to look at it and say, oh yeah. But
The only thing you can decide definitely by looking at it is that it's not a line. B is definitely not the correct answer. But whether the other options, you can't tell without writing it in center radius form. I'd like it better if it said write the equation in center radius form to decide, to describe the graph. But for the time being,
They haven't asked you how you want it worked.
maybe I'll tell, what's her face the next time she's on
call it
campus. I know. I won't say her name.
The Pearson.
The Pearson rep. Okay, so am I going to have to divide through the way we did with the last problem? No, we just group the x terms together. X squared minus 4x plus skip some space. Group the y terms together. We have a y squared plus 8y plus skip some space. And on the right-hand side, we have negative 29. And we still have the purple blank and the blue blank. What's going to go in the purple blank? Okay. 4 divided by 2 is 2. 2 times 2 is 4. I agree. The purple blanks get a 4. What's going to go in the blue blank? 16. 8 divided by 2 is 4. 4 squared. I agree with 16. And let's factor these x terms. X, be careful, minus 2. Remember, the sign in the parentheses is the same as that first sign you see there. Variable, sign, half of that number, plus, now the y's.
Y plus 4, I agree.
I agree. Variable, sign, half of that number. What have we got on the right-hand side? That's a negative 29 plus 20. We have a negative 9. What does that tell us about this equation? There is no graph. Because if you try to take the square root of negative 9, you'll get a 3i. Think about how we draw the little graphs. Can you move 3i units left, right, up, or down? No, you can't. That is an imaginary number. R equals the square root of negative 9 is imaginary. I guess you just have an imaginary graph floating around somewhere.
Well, but as soon as you added this up, did you have to do this over here? Once you saw a negative 9 over here, you could have stopped.
Mm-hmm.
Okay? So,
I just think
I
for a
still work
teacher,
left
I
to
would
right.
say it's a poor form.
Wait, no,
poor form to do that.
Wait,
So which one would we choose? There's not one that says there is no graph. D. The graph is non-existent. Like our best friend Mario would say, oh, whoever wrote this is trying to sound fancy. They're not going to say no graph. They're going to say non-existent. Yes. Okay, number 11. Same instructions. Hey, one of those A, B, C, D, we know that's not the case. I see the x squares and y squares, so I know which one cannot be the answer. Well, you think about that while I'm writing the problem down.
I'm not dividing the problem down too.
Oh, you think so? Let's.
Going back to this question, because of the exponents, we know which choice
Is not a possibility. That
Wrong.
it's a line.
Cannot
You
be
do that, check,
wrong.
Oh, excuse me. Let's see. Tree pollen and grass pollen will be very high this week.
And I have to say, it's sort of sad that you know stuff like that.
I check every morning.
The joys.
Joys of old
Going
age.
on.
Oh, let me check the pollen count. Oh, goodness. I'm letting y'all tell me what to do. Y'all seem to be mastering this, completing the squares, so I'm going to let y'all tell me what
How
to do.
soon do you, it won't happen, I think, during my career, but how soon do you think it'll be for just, y'all are sitting out there and we can just see whatever, y'all are writing on the little smart thing, but it'll show up here so the teacher can see everything that everyone's writing down.
I don't think I want to do that.
Yeah.
I don't think I want to see what they're
Yeah.
writing.
But I was going to say, if someone had done it, you'd show it. Oh, look, here.
Uh-huh.
Okay, so let's get started.
What
Great.
am I? Oh, okay. Tony, you just spoil all the fun. You just jump right to the chase, don't you? Cut to the chase. So we group the x terms together. X squared plus 12x. I was going to let them say. Plus, skip some space. Then what am I going to do? The y terms together. Y squared plus 2y plus skip some space. And then, I'm trying to. Okay, so a negative 28. And we still have the purple blank and the green blank. What number is going to go in the purple blank? 36. 12 divided by 2 is 6. 6 squared is 36. So you put the 36 and the 36.
Oh, darn. It's not going to be one of the easy no graph ones, is it?
Okay, what's going to go into the green blank? 1. 2 divided by 2 is 1. 1 times 1 stays 1. So 1 and 1. Let's factor the x terms. What am I going to have inside the parentheses? X plus 6, I agree. Variable, sign, half of that number. Now, the green parentheses, what's going to go there? Okay, variable, sign, half of that number. What have we got on the right-hand side? So, negative 28 plus 36 is 8, plus 1 gives me 9. So, is it a circle? Yes, it's a circle. We know it's a circle because this number is positive. So, tell me the center. Negative 6. Negative 1. Change sign, change sign. The radius, you take the square root of 9, which is 3. So it is a circle, and we were able to find the center and radius.
We don't have to graph this one, do we?
No.
Okay. So choose the option that is
It's
a
a
circle.
circle.
And what was that center?
Negative 6, negative 1.
If you don't put that in parentheses, it's going to count it wrong. Negative 6.
When you're doing your homework, you didn't
Negative
put in the
1.
parentheses, you can correct it. Can you do that on the test? No.
Radius is 3.
3.
Okay. Well, we've already done. Well,
Number 13. Number 13 is the last one. Number 14 and 15 are review problems. I think they're cut point problems. Isn't that cut point?
Odd's
that method
favorite is
ever
either
gonna
cut
go
point
over?
or quadratic formula. One or the other. Okay, so that's right number.
Number 13.
Are we going to have to divide through by something to get started on this one? No.
X squared plus y squared minus 2x minus 8y plus 17 is equal to 0. Once again, we know this is not a line because there's those squares there, the x squares and the y square. So switching over to my paper, I group the x terms together. X squared minus 2x plus skip some space. And then I group the y terms together. Y squared minus 8y plus skip some space. What have I got on the left-hand side? I mean the right-hand side. Negative 17. What's going to go in the purple blanks? 1. 2 divided by 2 is 1. 1 times 1 is 1. So 1 and 1. What's going to go in the green blanks? 16. 8 divided by 2 is 4. 4 times 4 is 16. I agree. So what have we got on the right-hand side? A 0. So is it going to be will the graph be a circle? It's just going to be that center point. Let's go ahead and factor. I hate to just stop at this point.
Well, this way you at least know, they don't ask.
But you'll know what the center point is. What will I have inside the parentheses? X minus 1, quantity squared. Now the green parentheses, y minus 4, variable, sign, half of that number. So the graph is a point. If you try to write out, if you try to find the radius, you get a 0. So the graph is a point. What is that point? 1, 4. They don't ask for that, but if you plugged in 1 here, 1 minus 1 is 0. 0 squared is 0. You plug in a 4. 4 minus 4 is 0. 0 squared is a 0. 0 plus 0 gives you 0. All you select, though, they don't ask you to state that point. They just ask you to choose that the graph is a point, but it's the center point. Any questions there? Any questions? Okay, I'm going to stop recording.